Imagine you create a file, be able to read it, who should be able to modify it. That's exactly what permissions control. Welcome back to the Linux Beginner series. Have you ever seen something like hyphen RWX, R hyphen X, R hyphen hyphen, and wondered what it means? In Linux, file permissions control who can read, modify, or execute files. In this video, I will explain Linux permissions in a simple, beginner-friendly way. Imagine a computer used by multiple people. We don't want everyone to be able to modify or delete every file. Permissions help protect important files and control who can access them. They are one of the key security features of Linux. The easiest way to view file permissions is using ls-l command. First column contains information about permissions. Let us focus only on the first part for now. This permission string is divided into four sections. The first character tells us the file type. For example, in this screen, you can see a regular file. The next three characters belong to the owner. The next three belong to the group. And the last three belongs to everyone. Else, once you understand these three blocks, permissions become much easier. Linux uses three basic permissions, that is read, write, and execute. Read allows you to view the contents of a file. Write allows you to modify or delete a file. Execute allows Linux to run the file as a program or script. For example, think of a recipe book. Read means you can read the recipe. Write means you can edit the recipe. Execute means you can actually run the instructions. Linux permissions are assigned to three categories of users. Owner, usually the person who created the file. Group is a collection of users who share similar acts. And others are everyone else on the system. For example, if I created a file notes.txt, I will become the owner of that file. These are common permissions example. In example 1, the owner can read and modify the file. Everyone else can only read it. In example 2, this is common for scripts and executable programs. The owner has full access. Everyone else can read and execute. In example 3, this is a private file. Only the owner has access to it. Linux also represents permissions as numbers. R is equal to 4, W is equal to 2, and X is equal to 1. We simply add these values together. For example, RWX read or write and execute value 1, and we add all these 4 plus 2 plus 1 is equals to 7. Similarly, RW hyphen means we add read and write, that is 4 plus 2 and it becomes 6. R hyphen hyphen means only the read permission is there, that is 4. One of the most common permissions setting is 644. 6 equal to read write hyphen, 4 is equal to read hyphen hyphen, and 4 again is equal to read hyphen hyphen. The result is this one. The owner can read and write, the group can read, and others can read. In real world, this is commonly used for normal text files and configuration files. Another common permission setting is 755. 7 is equal to read, write, and execute. 5 is for read and execute, and again 5 is for read and execute. The result is this permission setting. It means the owner has full access. Everyone else can read and execute. In real world, this is only used for scripts and directories. Now we'll see how to use the command chmod for changing permissions of a file. Let's create a file. And examine its permission. Now use chmod for assigning new permission. For example, 644 to file that we created. Now you can see the permissions have changed. Earlier it was read and write for owner, read and write for group, and read only for everyone else. Now the permissions has changed to read write for owner, read only for group and read only for everyone else. Is how permission string changed. Let's take another example. We created a sample script file and we can see its permission. The owner and group have read write permissions and everyone else has read only permissions. There is no execute permissions on the file. Using chmod, let's change its permissions. Now we can see that everyone has the execute permissions on the files. This command gives owner full access and allows others to read and execute the file. There is an alternate way for this. Let's create another file and see its permission. We can see that owner and group has read and write permissions and everyone else has read permissions. There is no execute permissions for anyone. So we can use chmod plus x and the file name. Instead of numbers, we have used plus x. And let's examine the permissions. We can see that now everyone else, everyone on the file has execute permissions. Similarly, to remove the execute permissions, we can use minus x and the file name. And let's examine the permissions. We can see that every execute permissions has been removed for everyone. So we have seen examples of using chmod command to configure two common file permissions that are 644 and 755. Now, what are the common beginners mistakes? Many beginners use 777 because it solves permissions problem. However, it also gives everyone full access, which is often unsafe. Another mistake is removing permissions accidentally. An example of another mistake is confusing files and directories. The best practice is to give only the permissions that are actually required. This is a quick reference. This table is a handy cheat sheet. You don't need to memorize it today. After using Linux for a few weeks, these numbers become a second nature. Let's summarize what we have learned and walk through this slide. Permissions control access to files and directories. There are three categories of users, that is owners, groups, and others. There are three types of permission for each user type, that is read, write, and execute. We can use chmod to change permissions of files and directories. 644 and 755 are very common examples of permissions. Now that we have understood permissions, the next logical step is to learn about Linux users and groups. We will explore commands like OMI, groups, and ID, and see how Linux identifies and controls access.